All right, so let's take a look at solving two-step equation. So basically, it's going to take me a couple steps to solve this. The first thing is very simple. The first question we hear is going to be very simple. Let me separate my sides through the equal sign to begin with. That way I see a left side and a right side. I want the term that has the letter by itself. So I want the 3x by itself. That -7, I don't want it there. So my -7, let me move it to the other side as a +7. Don't forget to switch the sign. So that gives me that 3x is equal to 18, right? 11 plus 7 gave me 18. Now, there's a number in front of the x, in front of the variable, in this case 3. Let me divide both sides by 3. Because 3 divided by 3 is 1. In multiplication and division, 1 is useless. So I'm just going to cancel it out. So I have that x by itself. 18 divided by 3 is 6. So my answer is 6. Now, when we mean solve, is that if the original equation, if I was to write a 6 instead of x, right, 3 times 6 minus 7 is equal to 11, I'm going to get a correct statement, a true statement, right? I have 18 minus 7 is equal to 11. Yeah, that's true, right? 18 minus 7 is 11. 6 is the only number that's going to give me a true statement. Now, any other number will give me a false statement. And what do I mean with the false statement? Something like 0 minus 7 is equal to 11. Right? That's false. So like I said, the only answer that will give me a true statement is x equal to 6. That's what we mean with solve. All right, now let's take a look at number 28. Couple ways how we can do this. We can move the 7 to the left and to the right side. But to be honest, the one thing that most people like, let me separate this. The one step that most people like are get rid of fractions. When you see a fraction, just get rid of it. I see the n over 10. So what I'm going to do, I'm going to multiply everything by 10. Some of my numbers are going to get big, but at least I'm not going to have fractions. Okay, so numbers are going to get big again, but at least no fractions. So I'm going to have 70, because 10 times 7 is 70, plus, good thing is that this 10's cancel out. So I get n is equal to 80. Notice I multiplied everything by 10. Some numbers got big again, but at least I have no fractions. Okay, I want the term with the letter by itself. So that's 70. Let me move it over as a minus 70. Don't forget to switch the sign. So I get that n is equal to 10, right? 80 minus 70 is 10. Again, what do I mean with the solution? On the original equation, if instead of n, you write 10, you're going to have like 7 plus 1 equals 8. That's a true statement, right? 10 is the only number that if I substitute it for the variable, it will give me a true statement. All right, let's take a look at question number 29. Okay. Again, let me separate my sides through the equal sign. Don't want to see fractions. I see a fraction. Interesting part is the left side, the whole thing is a fraction. I'm going to multiply both sides by 8. The left side, the right side, because this 8 will cancel out. So I have -7 plus p is equal to 8, right? On the right side, 1 times 8. So notice how with multiplication, I got rid of fractions. Again, that's my plan. I want the p by itself. So this -7, let me move it over as a +7. So I get that p is equal to 15. Right? Pretty simple. Let's take a look at number 30. I'm going to multiply everything times 8. Because again, I don't want to deal with fractions. So I have -72 plus n is equal to negative 56. Notice I multiplied everything by 8. This minus 72, let me move it over as a plus 72. Now, I have a negative 56 and a positive 72. When my signs are different, I subtract my value. So in my mind, I'm going to say 72 minus 56. So 16. Keep the sign of the large one, right? 72 was positive. That's a large number. So my n is equal to positive 16. Now, it's easy when it's all algebraically. This is what we call algebraically, right? It's in symbols. When it's in words, let's take a look at number 31 and 32. Change it to algebraically and then solve it. So it says on Tuesday, Deshaun bought 4 hats. On Wednesday, half of all the hats that he had were destroyed. On Thursday, there were only 19 left. How many did he have to begin with? All right. So in mathematics, when we don't know the value of something, we replace it with the letter. Usually we use the letter X, but it could be any letter. When we don't know the value of something, we replace it with a letter. So I'm going to say that to begin with, he had X many hats. I don't know. I don't know the value, so I replace it with the letter. On Tuesday, he bought 4. So I'm just going to say plus 4. On Wednesday, half of all of the hats that he had were destroyed. So all of these things, let me divide this by 2. And on Tuesday, there were 19. So now he has 19. I might not be able to solve for X. Okay, so I don't want fractions. So the way I'm going to solve this, let me multiply both sides by 2, because that way these things cancel out. So I have that X plus 4 is equal to 38. I want the X by itself, so the plus 4, let me move it over as a minus 4. Don't forget to switch the sign. So X is equal to 34. All right, so he had 34 hats to begin with. Right, 34 plus 4 would be 38. The half is 19. So yeah, it makes sense. Deshaun spent $27 on a magazine and some candy. If the magazine costs $2 and each candy bar costs $5, then how many candy bars did he buy? Okay, so let's take a look. He bought a magazine. So that means one magazine and some candy bars. So I'm going to say, I know the magazines cost $2 each. He bought one of them. So just in the magazine alone, he spent $2. Plus, he bought some candy. And each candy bar cost $5. I don't know how many he bought, but for me to know, I'm going to say $5 times how many candies he bought. So let me call this 5 times X. Remember, in algebra, mathematics, when we don't know the value of something, we replace it with a letter. So $2 for the magazine plus 5 times X for the candy. All of this is equal to 27. Now I'm going to solve for X. Right, let me separate him through the equal sign. I want the 5X by itself. So this positive 2, let me move it over as a minus 2. So I have 5X is equal to 25. Let me divide both sides by 5. So X is equal to 5. Okay, pretty simple. That's what we're going to do today.